Hello and GM everybody. Welcome to our Twitter space. Thanks for joining today, and we're going to talk about Aztec Sequencer and Proof of Testnet. We'll just wait a couple minutes to kind of let everybody tickle in. All right, I say we get it started. Welcome everybody again. I'm Amin here with Aztec Network. Today we're thrilled to be talking about the sequencer Proof of Testnet that we're launching pretty soon. This is a chance to kind of go through what it is, what our goals, and kind of what we hope to be doing through Proof of Testnet. If you're interested in kind of knowing all these things and just finding out more about how you can participate, please do stick around. I'm joined by two guests, sort of folks that I've been fortunate to work with over the past couple months on things like ProverNet and testing the proving systems for Aztec. Norbert, who's from Gavilot, leading Proving Marketplace, as well as Cohen from ZKFi. To kind of start off, just a really brief introduction about what Sequencer Prover Testnet is and what we hope to do. Sequencer. The main goals of Sequencer Proof of Testnet is really to test our sequencer rotation mechanism, right? So we want to make sure that we can kind of run a network that has multiple sequencers. These sequencers can be anywhere in the globe that can coordinate with provers. So sequencers build blocks and provers end up proving these blocks, testing that coordination, running some perhaps governance upgrades to kind of make sure that everything is going well. And to my knowledge, this is the first time that we'll be demoing an Ethereum L2 with multiple sequencers and permissionless proving, right? So this is pretty exciting. It's a major kind of progress in the field. And our guests today are two experts who know a lot about the space. So I'll maybe just give it up to Norbert. Norbert, would love if you could introduce yourself, Gavilot, kind of how your team came together, and what your core focus is.
Hi everyone. Hi Amin. Thanks for having us. Can you please confirm you hear me well?
Yes.
Okay, great. Thanks a lot for that. So thanks again for having us in this space. I'm Norbert from Gavilot. I'm doing protocol research, and I've been working with Gavilot over the past year almost. So basically a little bit of background, maybe the founders of Gavilot, Teemu and Thomas, they've been around in the space for quite a while. Teemu founded Equilibrium Labs, Equilibrium Group that built a bunch of core infrastructure with ZK projects like, I don't know, Zcash, zkSync, Alio, etc. And while in the ZK space, they were wondering whether there was a way to avoid 2-3 centralized entities becoming dominant in the proving space, since proving is going to be is a compute heavy task. They were thinking we should definitely try to build a network that can be a legitimate alternative to traditional cloud compute services, etc. So this is how basically the idea of Gevulot came about. And basically, Gevulot is building the first universal proving infrastructure. We call it ZK Cloud. It's supporting any proof system. We look to make it fast, cheap, and also decentralized. And we are super happy to have the chance to work with teams like Aztec Network, who share a bunch of these values with us, like want to go decentralized from day one, and we are super happy to be participating in the ProverNet. I mean, we participated in the previous one, and we are happy to participate in the next one as well. And yeah, excited to be here.
Thank you, Norbert. Cohen, giving the mic over to you. Love an introduction about yourself, what you do at ZKV, and kind of why you guys are particularly interested in ZK rollups and the zero knowledge space.
Yeah. Can you hear me? Okay. Just checking. Hello. Okay.
Yes.
Perfect. Yeah. Thanks for having me. So I'm Cohen. I do DevOps at ZKV. Together with some other team members. So ZKV, kind of as it started out, is a proof of stake validator. We're active on 12 different mainnet networks. Like an example of those are Celestia, the Cosmos Hub, Sui, Mina, Polkadot, but also some more. Outside of that, we're definitely very interested in experimenting with other systems. So like think for example shared sequencers, but also provers, like those kinds of systems. We're kind of working on. So we're currently working with teams like Aztec and Gevulot by participating in their testnets as both provers and sequencers, and giving them feedback on our experience with those networks, but also about the network design to kind of help them design these networks from the ground up. So yeah, I think that's a good overview. Passing it back to you, I mean.
Thanks, Cohen. So there's a lot of interesting topics here to get through today. Sequencer proof of testnet, testing a decentralized, sequencer rotation protocol, as well as a permissionless proving set, right? So these are kind of exciting developments in the space. I think Aztec is a leader in kind of bringing them to market. Before we dive into some of the topics, I really just want to maybe bring back the point that we're accepting applications for S&P Testnet. I think this is a great opportunity for folks to get to know what a decentralized sequencer rotation mechanism looks like, run some of the hardware requirements, get in early, and just experience kind of what Ethereum L2s can look like in sort of a decentralized state. We're accepting applications. If you have any questions about S&P Testnet, how you can participate, please feel free to leave them in the chat. We'll kind of get to those questions. And then towards the end as well, there's going to be a Q&A, so we can certainly get to any more questions at the very end. I'll, maybe just to kick us off, I think one of the things I was kind of, pleasantly surprised with is we recently ran ProverNet. ProverNet was a sort of a competition, sort of a testing environment where, we had multiple kind of proving operators who ran machines to prove ASIC blocks. It was great to see that folks were able to actually prove the ASIC blocks on time and kind of things went well. I know, Norbert, you mentioned kind of high machine requirements and proving times. I wonder if you can comment on sort of, you guys' experience during ProverNet. Were there any particular learnings that were interesting? Any kind of insights that you can share with us?
Sure. Yeah, happy to do that. Actually, first of all, I just wanna emphasize it again that ProverNet 1.0 was particularly a great experience, in my opinion, because it was the first real life test of like decentralized, outsourced proving for an L2, like in the entire space. So I think it's a very important milestone for the ecosystem, and I know that other teams are opening up as well. But I think it was really a very important and significant step forward for the ecosystem. And regarding the learnings, yeah, maybe let's start with some general ones. To be honest, it was really interesting for us to see what real world use cases would actually need in terms of proving capacity, in terms of orchestration, or any other requirements. So it's yeah, one of the main lessons learned was that a complex process like STAX block proving, where the prover agent first proves the correct execution of the transactions, the public functions of the transactions running certain circuits, and then the client-side proofs are converted into these honk proofs through running a tube circuit. And both of these steps are actually like have to be executed per transaction and are pretty heavy in terms of compute requirements and like proving times themselves. And then comes this tree-like aggregation of the proofs through the base merge and root roll-up circuits. So it was super interesting for us to see how this can efficiently be done. And like, like, okay, first of all, each agent has to have sufficient compute resources to efficiently handle the tasks that have to be carried out on every single individual transaction without being parallelized yet. And then we need to have a scalable network, where we constantly have enough resources to efficiently manage the parallelized parts and the proof tree like aggregation process itself. So the entire orchestration is again a key point. And then the whole custom integration that we went through in ProverNet 1, where we built a coordinator that actually delegates the proving tasks from STAX orchestrator to the Gabulot network. That was also a very, very interesting journey. Back then we had our DevNet running, which has some limitations because there was no horizontal scaling on our DevNet yet. So it was really hard to optimize it in a way that we can actually still generate proofs for STAC within the given 20-minute time window that was there for ProverNet 1.0. And we can submit back the proofs on time. On the other hand, another very interesting challenge was regarding the other track, which was not the custom integration, but running the STAC client as a prover node as is, because our main challenge there was basically to find the optimal hardware resources to be allocated for each prover agent, and to find the optimal number of prover agents to parallel process the different parts of the proving job. So we ran a bunch of tests with different parameters to find these optimal settings, and finally we ended up kicking off with 4 large machines and 10 prover agents each. This also included some redundancy, so that when the transaction count in each block was increased by the STAC team, then we were able to handle that load also with minor increase in proving time. But then we were also ready to scale up the infrastructure dedicated to this contest, to this testnet, and we're ready to add additional prover agents and allocate additional machines to be able to handle the increased block frequency. So it was really a complex task, and I can say my colleague Andre, who was doing the engineering part during the entire contest, he was actually fixing things and hacking things live on the go, which was very interesting again for me to see. And we were super happy to see that it is possible to generate these proofs on time, correctly for STAC, and we're super happy that we had great results in this Provernet.
Yeah, that was really strong performance. And yeah, I think looking back at Provenet, some of these performance numbers were, it's not just machines, right? Because you have to route these proving jobs to the different agents, kind of configure which agent is working on which proof in what order. So I think there's a lot of engineering that also goes into kind of optimizing performance. It was a really good opportunity to see kind of the work of Gavilod and the other participants sort of beat Aztec. I think I remember that we got 0 proofs in time. We lost in our own competition. We came to last place. So that was, it was good to see kind of people adapt at this speed. But yeah, maybe just to kick it off a notch here, during Provenet, we proved really small blocks. It was, I think it was like one transaction a block. And, considering that kind of modern rollups have larger throughputs, I think the proving requirements are going to scale up pretty quickly. I wonder if Norbert or maybe Cohen, wonder if you guys have ideas on kind of what are some of the trends you're seeing in the decentralization of prover networks. Like, is this something that we're going to need, in your opinion, to be able to meet the demand that's going to come from this newer generation of, zero knowledge rollups or blockchains that will need proving infrastructures to prove things at a high throughput?
I think, from my side, what I see is that more and more teams are exploring these so-called continuations, like the parallelization of proving and making proving much more efficient. So I think in that sense, efficient orchestration and any prover network being able to efficiently handle those complex tasks, which include a bunch of workload, like allocating different tasks to different provers, running an optimal number of tasks on one single machine, then aggregating those tasks. So it's becoming more and more important. With specialized hardware, I think the landscape will become even more interesting, because we'll see what difference they will be able to make in terms of capacities and how it would affect parallelization efforts or the necessary orchestration. But I think, like you mentioned, I think in the blog post about the sequencer prover testnet, that the STAC team is basically looking to also test around 1 TPS, proving epochs with around 1 TPS. And that's absolutely, that's not a high number when we look at, so that's an absolute realistic number when we look at, the users interacting with an L2 in the space. So I think it's gonna be and even to be able to keep up with that type of load requires a whole lot of optimization and orchestration and a lot of compute resources. So I think the importance of prover networks being able to manage those resources and manage those workloads and have the necessary resources available at all times is going to increase. And as more and more rollups are starting to decentralize their proving, I think we are experiencing a very interesting era where most of the rollups have been running in a centralized fashion, both sequencing and proving. And STAC is one of the leaders there, decentralizing the whole stack, and even launching the whole stack decentralized from day one. So I think it's going to be very interesting to see how it plays out. Over to you, Cohen.
Yeah. So actually, like I think we're very aligned on this, Norbert. And Norbert and I have talked in depth about some of this stuff, so I think we have similar opinions. But I think one thing to add here is also like I think the co-starking development, or like co-starking technological advancements that are happening now. So like kind of being able to do distributed proving, but also like hide the witness between the different provers that are actually producing the proof is a really cool development. So I think Takeo, I'm still unsure how you say it, but that team is working on it, and it's like really cool stuff there. Like that I think in general is going to make us going to be an answer to some of these questions. Like I think that in general in the proving ecosystem, there's still a bit of a question of how are we going to allocate compute power, right? So you could in theory just kind of decide we're all going to run on like one prover net, like kind of like Gavelot. But from a node operator perspective, like you might say, okay, well, we want to run on Gavelot, but we actually also have this opportunity of running directly on Aztec or directly on any other kind of network that requires proving. So kind of building out tools or tooling where you can kind of properly allocate your resources and your compute power, and also preventing it from just sitting idle. Like that can be an issue, kind of that I'm thinking about a ton, which is like, well, if I invest in all these and all this really heavy compute, like specialized compute, especially whether it's FPGAs or GPUs, I'd rather not have those sit idle, right? It will cost money in the long run if they just sit idle. So yeah, those are kind of still unanswered questions, and node operators are kind of in there trying to solve those, which contributes to that as well.
That's a really interesting observation. I think you mentioned kind of as a node operator, the decision of like, am I producing proofs for Aztec? Am I sort of sending my compute somewhere else? That could be a pretty difficult optimization problem and kind of load management, hardware management. Just thinking of the role of proving marketplaces, maybe Norbert here, given kind of your expertise, is that a problem that you guys hear often from node operators? Is that something that you're optimizing for when building Gavilot?
Well, I think like as a team building proving infrastructure, and okay, sorry, let me approach it from a different angle. I think prover networks and the capacity or the capability of prover networks to aggregate workloads from multiple sources is going to become very important, because that's kind of one of the way to optimize for minimizing your idle time as a node operator. Obviously, we are working with different node operators, with a ton of node operators actually, and looking to have a very decentralized set of prover nodes in our network. But like from our perspective, considering whether, like if I put myself in the shoes of a node operator, whether I would keep a huge amount of machines available in case I win a bid for a very heavy compute, like proving workload. And then depending whether I actually do win that bid or I need to, basically I lose out on the time until the next opportunity to bid comes, is a very heavy question. While if I, as a node operator, join a network that actually can serve me proofs constantly from different sources, and I can reach a much higher hardware utilization, and through that a much higher revenue potential, then that could be a very, very interesting topic. I think that for example, we've been talking a lot about this, and for example, for ProverNet 2.0, for the sequencer prover testnet that Aztec is planning, and I think you also mentioned in the blog post that there would be something like maybe close to 1,000 prover agents needed at one TPS to prove an entire epoch on time. That's a capacity that is very rare to just sit idle and wait way to jump on a proof. So I think optimizing that type of idle time versus hardware utilization and revenue potential is going to be very interesting.
Yeah, I think I was reading recently about an interesting comparisons to, between proving marketplaces and sort of the Bitcoin mining pools, but I'll get to that maybe later down in the space. Uh, in sequencer proof of testnet, provers will be, the way that kind of it's going to work is that, uh, not unlike how it works on Ethereum, every block, we'll have one proposer who kind of proposes a block, and then at the end of the epoch, there's going to be an auction. So provers will submit bids to sequencers, and then sequencers will sort of pick the best bid, or pick the prover that's most reliable, kind of based on their past performance or on the bid parameters, and then they will kind of assign the proof to a single prover. Now, this is in kind of contrast to some of these other models that maybe I've seen other networks try out, like proof racing, for example, where anyone can produce a proof, and then it's kind of first come, first serve. I wonder if, and maybe this is to Cohen, and feel free to jump in, Norbert. I wonder if you guys have thought about the different economics, um, the different economic models of like proving systems, whether it's proof racing versus kind of a single proof system. Wonder if you can maybe give a brief summary of how you guys are thinking about it right now.
Yeah. Like when it comes to proof racing, I think, like in my opinion, I don't think that is a very sustainable model that we should go for. Mainly due to kind of the reason that at that point we're really looking at something that's kind of very similar to mining, because having more compute power will mean that you will produce that proof faster, as long as it's posted as fast as you can prove it. And the chance of getting a reward with the larger amount of hardware or more intensive hardware is bigger. So like it's incentivized at that point to just buy more hardware, which is similar to what mining is. So I think in a way, this kind of the way I see it now, there's kind of two systems that we're kind of seeing, which is kind of system that Aztec is taking, which is where we're just going to have people bid. It's going to be kind of like a reverse Dutch auction. I see, and but that's one way of doing it. The way that Givelot's doing it is more kind of we're collecting Givelot's kind of creating a quote for, or you can create a quote or get a quote on Givelot for how much it will take to create a certain proof, and how long that how fast you would want that to take, like how fast you would want that to be done. So two systems, both have ups and downsides, I would say. Maybe Norbert, as the kind of person from GovLots who picked the opposite one, has an opinion on why his is better. But I think both have a good reason for existing.
Norbert, did you
Yes,
want to perhaps add
maybe.
something?
Yeah, maybe from my end, I just add that, yeah, you mentioned proof racing, and definitely because of the amount of redundant computation or wasted computation, depending where you look at it, which angle you look at it from. So proof racing is never going to be the cheapest option, because at the end of the day, usually it's the user who has to pay for those, for that redundant computation. On the other hand, so it's not a very efficient method to drive down costs. Auctions are actually a good instrument to drive down costs. So since you mentioned economics, I'm touching a bit on this as well, because it creates an open platform for to price proofs. On the other hand, like, we indeed went a different route, because we felt that auctions are not the only way to decrease the cost of proving. So our route includes basically having an L1 a very minimal L1 underneath Gevulot, managing workload distribution, reward distribution, economics, etc. And by being absolutely independent from any other network out there and non-dependent on the economics of Ethereum or L2s or other networks, basically we are able to, and that's what we are doing, we're designing our economics in a way that we can make proving drastically cheaper than what's out there currently. And with that, and with the additional like protocol level fallback mechanisms, execution guarantees, protocol level decentralization, etc., we think we can be very competitive and possibly actually potentially even cheaper than auctions. One thing I would actually emphasize regarding auctions, and that's, I think it has to be noted that an auction within the context of prover networks or an auction to source proofs for an L2, it's a little bit different because in a prover network, auctions may mean heavy centralization, which means that some powerful entity could come in and underbid everyone else for a considerable amount of time until basically competition is out of the way. They've gained dominance, and then they can start controlling cost structures. They can start controlling, or they can start like, okay, let me put it this way: the censorship risk would increase, etc., whatever it comes with. So it has a centralization aspect that I think is very important, and because we wanted to maintain as wide decentralization as possible, we consciously decided to rather build economics to be cheap on our network and like bake it into the protocol and not go with auctions because they are much more susceptible to centralization.
Like, I think even if I kind of look at that from the Aztec perspective, right, in the way that they're designing their network, like in a way, the auction system is going to get the end user or the actual like people who are doing transactions the cheapest price of being able to do these, or like of being able to kind of do things on this network. So like, you know, from the Aztec perspective, it's actually a good reason for picking it. And like, I think there's enough kind of, people have thought about this enough to the point when now where there's actually, there's been some pretty cool models, thought through of how we can kind of connect these two things together. And how, like, for example, Gavlot can run on Aztec, and kind of be able to, you know, with those two different pricing models still function. So yeah.
Or, you know, while still on the topic of economics, are you seeing, from the experience of working with perhaps other networks or other folks, that have demand sort of for proving needs? Have you seen sort of the emergence of one of these economic models over the other? Like, would you classify kind of, you mentioned proof racing is ultimately going to be expensive to the end users of the network. Is that kind of becoming a learned lesson in terms of the networks, or are people still experimenting and this is still kind of an open question?
I think from what I'm seeing, most networks aren't going with proof racing. Like most are trying to find a different model, whether it's kind of a hard tying in with a one and ideally more different prover networks like Avalon's, but also other options, and kind of following the price that they give using their quote system. So yeah, I think it depends on the actual network, but I don't see a lot of networks doing proof racing right now. Yeah, and I personally would try to discourage them from going in that direction. But maybe Norbert has a take here.
Yeah.
No, I don't really see proof racing either as an option or as a method that would be applied by networks out there. Actually, I think auctions seem to be quite a popular one among prover networks or marketplaces. On the other hand, there are very few, I think very few, not even sure who else beside Gevulot, who rather goes with random selection, and like a more neutral setup that random selection can produce when it comes to distributing workloads, and approaching the economics that way. I think it's still to be seen. There are some order book based mechanisms out there as well, similar to auctions, but still a bit different. It's still to be seen. I think we are making best guesses here, or most of the industry, I think, is making best guesses here. But there are some good signs that it's possible to make proving cheap even without auctions, which we are super happy about. Personally, I get a lot.
Yeah. Yeah, those are great
Maybe even
perspectives. Yeah, go ahead, Con.
I was going to say, maybe even to add to that, like there's some things that I kind of think are really cool, in terms of, like optimization for client-side proving as well. Like if we can get client-side proving to the point, like whether it's through hardware advancements or through, software advancements, like if we can get client-side proving to the point where, you can do most of the proving that you need to do locally, and then there's kind of a, more of a just kind of a sequencer role that's left to do on the actual L1 or L2 that you're posting to. Like that would be amazing, but it will take some time to get there, right? Like if we're kind of looking at what it requires to run Aztec now as a prover, or like what it's going to require in terms of compute, like it would be cool if we can do a lot of that stuff on device. So yeah,
Yeah.
that's like
I guarantee you that we have some folks at Aztec who are like clapping right now. You know, we're also big into clients improving, and there's been a lot of progress done. I'll say specifically on the clients improving and not really hardware, but more so on like cryptography to make sure that folks can produce these proofs faster. But we're not at a point there. We're not there to the point where like the entire kind of proof can be produced client side. But yeah, super agree. Maybe just like one last comment on the whole economic side of things. I mean, our experience in Aztec has been, proof racing is ultimately going to be super expensive. If you think of kind of the user's boring, kind of taking on or absorbing the total cost of proving, having multiple provers compete, where all but one of these provers will end up kind of wasting their compute. The user is essentially paying for extra. Think of it as censorship resistance or guarantees that someone out there will eventually produce the proof. Whereas with an auction, the cost is way less. But there's certain risks from kind of assigning the right or the responsibility of producing a proof to a single prover. Is the obvious question is what if something happens, what if their nodes go off, what if their electricity shuts down and they can't produce a proof, right? You've just essentially either delayed the network, causing kind of some liveness issues, cause the reorg, depending on the network design. And I think there's centralization vectors in both designs as well. Like when you think of a fast prover that's winning 100% of the races, that's certainly a centralization vector. Unlike Bitcoin mining, right? You can have the fastest machine on the planet. You're not going to be winning 100% of the proofs. Or you're not going to be winning or finding 100% of the block rewards in Bitcoin. Whereas in proving, if you're the fastest machine out there, you're winning 100% of the races. But there are other centralization vectors in auctions as well. We talked about a prover with very large resources who can sort of underbid everybody for an extended period of time. People will eventually leave, and then that leaves only them, right? So yeah, it is an interesting It is an interesting design space, one that we're actively still thinking about. I guess bringing it back to sequencer proof of testnet. What are you kind of looking forward to testing the most? I mean, there's certainly going to be, we're certainly going to test, if the auction mechanism kind of behaves well, and we'll see kind of how different provers and their different strategies in bidding and what sequencers react to those strategies. Are there any other maybe things or aspects of the block production system that you're looking forward to testing during the S&P testnet?
yeah. I'm really excited for that testnet. I think it's going to be super interesting to see.
think maybe Cohen might have went on mute. Norbert, I don't know if you can maybe take that one on until Cohen is able to be back.
Yeah, sorry.
Oh, there we
The
go. Okay.
yeah. So like I kind of want to do a quick look back at the other prover network that we just had, or that we kind of finished, I think, a few weeks ago. So like some of the things that I really enjoyed there were like the good communication from the team. Like I was really surprised and really happy with how fast we got kind of responses from the team, and any technical issues that we ran into resolved really quickly, like without, or at least we got communicated about it really quickly. Like at any hours of the day, we would get very fast replies, which is great. But also it's like we had a Telegram chat with all the other provers that were on the that were kind of running provers on that network. And just the banter in there was really fun. Like I think some people in there we were running memes. Steve was kind of Steve from Aztec
Shout out to Steve, yeah.
yeah, was sending funny things every other day, and that just caused a lot of people to reply in funny ways. People showing off their 100 gigabit switches that they were installing, that kind of stuff. So yeah, that was all really cool. I'm looking forward to that again in this next testnet. So yeah, the vibes were definitely there, if I can say so. And then kind of looking forward, like I think experimenting with this prover system, in a way where with combined with the bidding, is something that I'm kind of excited about, and seeing what it will do and how the hardware will also react to it. Especially with this level of kind of compute required, and seeing what that will do. So yeah, there's always, it's going to be really cool to see how that works. But also kind of the sequencer, because in the last network we didn't have a sequencer running. We only had provers, and Aztec was running the sequencer. So yeah, it would be cool to kind of see once we run a sequencer how that will behave as well. So yeah, I think that's kind of that's kind of from my side. Maybe Norbert has a good take too.
From our side, I think we are going to be focusing more on the proving aspect, but planning to run a sequencer ourselves too. The thing is, I think the epoch proving is taking the challenge to the next level, basically. So we are super excited and interested to see how the next version of our network, Firestarter, which is designed to be scalable and like be able to handle this type of complex workloads, will be able to do the epoch proving and perform on Aztec's ProverNet 2.0. So we are really looking forward to seeing that. It's going to be an actual real live test of our network as well, not just like how it performs for such a task of epoch proving. But also, it's going to be very interesting to see how the bidding goes. Indeed, as you mentioned, I mean, how sequencers will react. I'm curious to see, though, since it's a testnet environment, to see how much we can actually mimic kind of sequencer behavior, or like from a game theoretic perspective, or like from like mainnet type of behavior, how much we can mimic that in the testnet environment. But definitely super interested to participate.
Me too. I think all of these things are going to be super interesting. For those unfamiliar, epochs are blocks of 32 blocks that have to be proven at the same time. So the kind of the proving load is much larger than the previous prover net. And it's going to be exciting to see. We're not going to run at a significant throughput for most of SMP testnet. I think we want to run at a calm throughput. If you think about kind of during the later stages of SMP testnet, we're going to have 100, 200, perhaps even more validators who take turns to be sequencers. These sequencers can be, someone could be in Tokyo, another can be in, New York, and from our perspective, it's going to be really interesting to test kind of some of the limits of the system, like, how fast can a data packet travel? If the validators who are present, really, really in very dispersed geographical areas with very different setups. I mean, we're onboarding institutional operators. There's going to be home stakers, kind of individual, people who run nodes at home. It's going to be interesting to see how kind of they're able to coordinate. I do agree that we might not be able to see very sophisticated kind of auction strategies, but you never know. I think, yeah, maybe we'll be surprised. Maybe we'll be surprised. Maybe just I had a different question actually. Perhaps this one is more for Cohen. Um, running validators on networks is not something new, but running sequencers on L2, again, to my knowledge, this is the first time that a network launches with a decentralized sequencer set. Just very high level, do you think there's any different, are the challenges different in sort of maintaining the node software when you're running, a validator or a full node versus, an actual sequencer node?
Yeah. So like if we're comparing like an actual validator on a network versus versus a sequencer that you would run on Aztec, like it's actually in a way that there are slight differences, right? So you'll need to have access to the L1. You need to be able to post transactions there, or like you need to be able to post data there. So like in that respect, it's slightly different, but in a way, it's actually very similar. Like from a
Yeah.
node operator perspective, we're not talking about massive differences. We're talking about, okay, well, the software is a little different, and it might need an external dependency, like a connection to an L1. But outside of that, most of the time it can be quite easy to run.
Yeah, it's pretty similar. Sequencers, validators. I think that's a good point on the interactions with L1. This is a bit of a this is a bit of a trendy one. But do you think we're trending in a direction where the requirements to run a sequencer node are trending up or down? I know there's been some discourse around that in the past, and curious to how you're seeing other networks implement this.
Like as kind of comparing a sequencer against a validator, like the hardware requirements are going to be are
Yeah,
sorry.
given that maybe there's not a lot of decentralized sequences, that maybe we can just keep it to full nodes. I know there's a
Yeah.
slight difference there, but
Yeah. In a way, you have slight, like the hardware requirements are going to be slightly less. And I actually don't think that they'll necessarily be trending upwards. If anything, I can see them trending downwards because the complexity of a sequencer isn't necessarily as high as the complexity of a validator or even a full node if we're talking about that. Just because of kind of the operations that a sequencer does versus what a validator would do. So yeah.
yeah. I think this is something that we're taking closely into mind, developing the sequencer clients. Like, obviously you can cut some corners by, requiring, data center grade sequencer nodes. But yeah, one key element is, censorship resistant decentralization. We really do want, um, a variety of different node operators to be able to participate, especially in sequencer and proof of testnet. Um, so I guess this has been a driving force for us in kind of just keeping the requirements relatively simple. I think, I think bandwidth requirements are, slightly, challenging depending on where you are in the world, but we're confident that there's going to be a lot of people who can sort of run this thing from, hopefully their home. I mean, that's ultimately the goal, right? Is to enable everybody, to run, a node, but a sequencer node. Why not? Um, we're drawing up maybe towards the end. If you do have questions, please raise your hand or kind of put them in the chat. Happy to take some questions now or towards the end. I want to give the opportunity to Norbert and Cohen to maybe, if you guys want to show something, or talk about kind of what thing or exciting developments have been going on, or what you guys have been working on, I think this is a good time to do it.
Yeah. I don't have much to share outside of we're a proof stake validator on many networks. Maybe like one thing to share is in about 40 minutes. So in well, I don't know what time zone that would be because time zones are confusing. But yeah, in about 40 minutes we're gonna have another Spaces with Celestia, kind of celebrating their 1 year anniversary. Yeah, looking forward to seeing anyone else there. Yeah, I'll give the space to Norbert to share something because I actually had a follow-up comment. Yeah.
Thanks. From our side, basically, we are heavily focused on building Firestarter, the next version of our network. It's a scalable, production-ready network. Basically, the permissioned version of the ZK cloud that we are building ultimately. And with this one, like we had quite some limitations, for example, on ProverNet 1.0 with our DevNet because of like, for example, the lack of horizontal scalability. Like all these things are gone with Firestarter. So we are very excited to support any decentralization initiative basically. And we are super happy to be contributing to STAC to test decentralized proving and to be part of that, part of this upcoming sequencer prover testnet as well. Yeah, I think, let's see how it works out. Looking forward to working with you guys, and thanks a lot for the opportunity to be here.
Awesome. Yeah, maybe just one last show from my side. If you, in the meantime, if you do have questions, again, I'm happy to bring up folks on the stage if they want to ask some questions. But I just wanted to repeat, we're still accepting applications for the S&P testnet. If you're interested in running a sequencer node for, it's actually the first time you're going to be able to run a sequencer node. So if you're interested in running a sequencer node, seeing how that works, we have an application form. You can sort of go to our Twitter page and you'll see a link that should be up there. It should not, we heard some crazy applications taking 8 hours. This is nothing like that. I think we're looking for folks that have the right sort of mission alignment with Aztec, who are, interested and capable of running a sequencer node. So yeah, check us out. Please fill in the application. I think we're targeting a deadline of the end of this week, early next week. So be sure to, kind of get on that quick if you can. There's maybe a couple questions that.
Yeah, I was going to actually give a follow-up comment about the decentralization, if that's okay.
Yeah, of course.
Yeah, like one thing that I'm actually really passionate about is decentralizing even existing validator sets, and sequencer sets as is, right? So I think even part of that outside of, what would be really cool is we can actually run, people can run their sequencers at home. Although, most of the time that's not always, a possibility that, is going to be very reasonable for everyone. But even then, like it would be really cool if a lot of validators actually spend some effort trying to decentralize their own validator node. Just running them in a cloud provider that is already overpopulated with other validators, or running them in the same data center as many different other validators or sequencers. Just kind of geographically spreading out the validator sets is something that I'm really passionate about and I'm spending a lot of time on. So yeah, I think if anything, I would encourage node operators to kind of work towards that, and that's kind of what is exciting about shared sequencers as well, right? Instead of having the single sequencer or a glorified multi-sig for an L2, we're going to have actual decentralization in that scenario with Aztec, for example, which is really cool.
Absolutely. Yeah, all really great points. I think on the forum we ask folks, if you do run it, if your intended setup is in the cloud, what data center are you running from, what country? Yes, please. Yeah. I don't know if I have any stats on the top of my head on what cloud providers are running the most nodes, but I think the gold standards are home stakers. I know this is difficult, specifically maybe for some of the newer networks with the high bandwidth requirements, but if you can even just spend a little bit of time to understand, why this is important and kind of what are some of the steps that you can take to slightly help diversify the validator set of Ethereum, of other networks. I think this is something that is very much net positive. Two questions in the chat that I see. Have you selected validators for testnet? No, we're still accepting applications. If you have experience running any sort of node or running testnet, and you like what we're building and you share kind of the same vision that Aztec is building towards, we want to hear from you. So please, you can find the Twitter space, the Twitter page for Aztec, and I think that should be one of the last tweets up there. And then what system specs is recommended for this, and how long will the testnet run? The testnet will run for about a month, so 4 to 5 weeks, leading into a more kind of public testnet where it's permissionless. So I think applying for sequencer proof of testnet is gonna give you some time to test and kind of figure out your setup and maybe develop some interesting bidding strategies that we were just talking about earlier. Yeah, I think it's an interesting time to kind of join. So with relation to system specs, I think they're pretty standard for nodes. I don't have anything on the top of my head, but if you kind of head over to the application, you will see a recommended spec on there. And yeah, before we wrap this up, there's no more questions. Before we wrap this up, Norbert, Cohen, thank you so much. It was a pleasure talking to you guys today. Looking forward to working, and seeing how you guys do in sequencer proof of testnet. And yeah, hopefully we'll see more of this decentralization effort, kind of more industry wide in the future. Thank you so much.
Thanks for setting this up.
Thanks a lot for having us.